Hello students, in previous classes we discussed mainly the integration of algebraic functions and integration of trigonometric functions by the method of substitution. While continuing the discussion of the integration of algebraic and trigonometric functions, we discuss integration of exponential functions, integration of logarithmic functions and integration of inverse trigonometric functions, and the same functions obtained as combination of these. When the integrand is the product of two functions, the integral can in same cases be expressed in the form of a simple integral which can be evaluated by the rule of parts. So in this class we are going to discuss one more method of integration that is found quite useful in the integrating product of functions. So here we are going to discuss about integration by parts. So what is the integration by parts rule? Look at here, if u and v are two functions of x, then integral u into v dx is equal to u into integral v dx minus integral derivative of u into integral of v dx whole dx. Let us see how we will get this rule. We know that for any two functions f of x and g of x, we have d by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. So this is the product rule which we discussed in differentiation chapter. Okay, now integrate on both sides this one with respect to x. Then what we will get? See this step, integral f of x into d by dx of g of x plus g of x into d by dx of f of x dx is equal to integral d by dx of f of x into g of x dx. Just we integrated this step on both sides. Now from integration we know the basic rules. So see here, integral sum of two functions dx is equal to the sum of individual integrals of the functions. In the same way, one more rule, derivative of integral f of x dx is equal to f of x, or integral of derivative of f of x is also f of x. So by applying the first rule on left side part and by applying second rule on left side part, what we will get the new step? See here, integral f of x into d by dx of g of x dx plus integral g of x into d by dx of f of x dx is equal to f of x into g of x. Now from left side, the second term we can shift to right side. Then what we will get? See here, integral f of x into d by dx of g of x, this term as it is, and this term we shifted to here right side. Then f of x into g of x minus integral g of x into d by dx of f of x dx. Now here the function f of x we are taking as a new function, that is u. So let f of x is equal to u, and d by dx of g of x function we are taking as v. Then if we integrate this function on both sides, then what we will get? Integral d by dx of g of x. By using this rule, integral d by dx of g of x, how we can write? Integral v dx. So by assuming f of x is as a new function u, and by assuming d by dx of g of x as a new function v, then g of x we can get like this, integral v dx. Now by substituting f of x is equal to u and g of x is equal to integral v dx in this step, then what we will get the new rule? See here, so integral u into v dx is equal to u into integral v dx minus integral derivative of u into integral of v dx whole dx. So this is this rule is called integration by parts. So this rule is called integration by parts. So we discussed till now the integration by parts rule. So this one is our integration by parts rule. So this integration by parts rule can also be remembered in this way. The integral of the product of two functions is equal to first function into integral of second function minus integral of derivative of first function into integral of second function. So this one we can remember in this way. In differentiation, while we are applying product rule, we don't have proper restrictions this one is first function, that one is second function, like that. But in integration by parts, we have a proper choice of first and second functions. So by following this process only, we can apply the integration by parts rule. Integration with the help of this rule is called integration by parts. In the above rule, there are two terms on RHS, and in both the terms, the integral of second term, see here, integral v dx, integral of second term is involved. Therefore, in the product of two functions, if one of the two functions is not directly integrable, like log x, sin inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosecant inverse x, like this. So we take it as a first function. We take it as first function. The remaining function what we have in the integrand, that we can take as second function. So the remaining function is taken as the second function. So look at, see one example. See here, integral x sin inverse x. So here x is one function and sin inverse x is another function. In this type of cases, inverse trigonometric function sin inverse x we have to take as first function, and the remaining function x we have to take as second function. Look at another example, integral x square plus 1 into log x. Here logarithmic function we don't have direct integration. So log x function we have to take as u, that means first function. Then the remaining function x square plus 1 we can take as second function. That means the remaining function is taken as second function. Okay. If there is no other function, then unity is taken as the second function. Example, see here, integral log x dx. Here we don't have product of two functions. We have only one function, that is log x. Look at here one more example, integral tan inverse of root x dx. So here also we don't have two product of two functions. We have only one function, that is tan inverse root x. In such cases, we have to take the second function is the unity. That means 1 we have to take as the second function. Suppose if we take 1 as the second function, then the rule of the integration by parts can be applied to integral f of x dx by choosing the second function as unity. That is, integral f of x dx can be written as integral f of x into 1 dx. That means if we apply by part rule here, that means this rule. So this rule if you apply here, first function is what? F of x into integral of second function, one integration is x. So x into f of x minus integral derivative of first function, f of x derivative is f dash x into integral of 1 is x dx plus c. So in the given integrand, if we have only one function like this log x or inverse trigonometric function, like this if we have only one function, second function we have to take as unity. Okay. If in the integral both the functions are easily integrable, if in the integral both the functions are easily integrable, then the first function is chosen in such a way that the derivative of the function is a simple function and the function thus obtained under the integral sign is easily integrable than the original function. I will explain this point clearly here by taking two examples. See here, the first example is integral x sin 3x dx and the second example is integral e power ax into sin of bx plus c dx. See here, the integration of x we can find easily and the integration of sin 3x also we can find easily. And here e power ax integration we can find easily and sin of bx plus c we can find easily separately. So in this first example, x sin 3x product of two functions are there. These two functions individually we can find the integration easily. Here also we have two functions, product of two functions. Individually these two functions we can integrate easily. But to apply the by parts rule, what is the condition we are using here? See, if in the integral both the functions are easily integrable, then what we have to do? Then the first function is chosen in such a way that the derivative of the function is a simple function. That means, see here, what is the derivative of x function? 1. And then what is the derivative of 1? 0. Here, what is the derivative of sin 3x? 3 cos 3x. And then what is the derivative of 3 cos 3x? Minus 9 sin 3x. And then what is the derivative of this one? Minus 27 cos x, cos 3x, like that it will continue. So it is not a simple differentiation, it will continue infinitely. But here if we do the derivative of x function, you can do the derivative simply here, that means 1 and then 0. That means the derivative of any function is approaches to 0 after doing many times. That function we have to take as first function. But here if you see in the second example, e power ax derivative is a into e power ax, and then again differentiate, this means a square into e power ax, and then again differentiate means a cube into e power ax, like that it will go, there is no end. Similarly here sin of bx plus c derivative b cos of bx plus c. If we differentiate this one again, b minus b square sin of bx plus c. If we differentiate this one, it will continue, there is no end. That means in this first example, x function we have to take as u function, that is first function, and sin 3x we have to take as second function, that is v. So why? Because the simple function is here x function. But in the second example, if you see here, in these two functions, which function we have to take as first function u, and which function we have to take as second function v. So there is no restrictions in such type of cases. Any function we can take as u, any function we can take as v. That means e power ax is u, sin of bx plus c is v, or sin of bx plus c is u and e power ax is v. So any function we can take as a first function. Okay students, see here one small trick. In the previous part we discussed many cases. Now to remember all these cases it is very difficult. So we can also choose the first function as the function which comes first in the word IIT. So what is this IIT? I will explain this about IIT. So IIT, what is IIT means? I stands for inverse trigonometric functions. Example, sin inverse x, cos inverse x, tan inverse x, like this. L stands for logarithmic functions. That means log x, log of 3x plus 4, log x whole square, like this. And then A stands for algebraic functions. Example, x plus 1 whole square, x power 4, x square plus 1, like this. T stands for trigonometric functions. Example, sin 3x, sin secant square x, cos x, like this. E stands for exponential functions. So exponential function means e power x and a power x. Such type of functions are called exponential functions. So if we have product of two functions in the given integrand, by using this IIT rule we can choose the function u. That is, in this word which letter will come first according to the given integrand, that letter function we have to choose as first function.